in this particular video, we'll be discussing about 4 into 1 multiplexer. In our previous video, when we started our discussion with the introduction of multiplexers, we took an example of 2 is to 1 multiplexer. So in this video, we shall try to take up the next type of multiplexer, one of the type of multiplexer, that is 4 cross 1 multiplexer. So how to draw your 4 cross 1 multiplexer is our main agenda over here. Guys, it's very simple. As soon as you know what is the input, what is the total number of inputs, it is 4 inputs which produces 1 output. As I know the number, my second thing is, I need to know what is the total number of select lines which I need. Okay. So in that case, we have the method to follow to calculate the select lines. So how to calculate the select lines here? My inputs is 4, that is n is equal to 4. What is the formula? That is to have the select lines, m is equal to log into base 2. What is my n value? N is 4. So log 4 to base 2. 4 can be written as 2 power 2. So it becomes log 2 power 2 to base 2. Then if I take 2 this side, it becomes 2 log 2 to base 2. We know that from the logarithms, it is log, if it is in the form of log a to base a, it is always equal to 1. So it's so that it becomes m is equal to 2 into 1, that is 2. So that your multiplexer, your 4 cross 1 multiplexers requires 2 select lines for your multiplexer. Okay, that is first step. Second step, how to, I will be writing the block diagram of your 4 cross 1 multiplexer. So I am having 4 cross 1 multiplexer. Here I am having 4 inputs, I0 to I3. Next I am having Y as my output. We need to know what is the output circuit it is generating over there. Next is writing the truth table for the existing circuit. What is the truth table for this? Okay, if that's the case, see here, I have my select pins, that is S0 and S1. Okay, if there is 2 select lines, what are all the possible combinations which I can have here? That is 4 possible combinations: 0, 0, 0, 1, 1, 0 and 1, 1. If the select lines are 0, 0, it produces I0. Next, if it is 0, 1, it produces I1. If it is 1, 0, it produces I2. If it is 1, 1, it is I3. So how it will be selecting? That is in my previous video, I have told you that there will be a diode over here. With the possible combination, it just try to have the connection with that particular input only. Okay. So now after writing this, we need to write the output equation. So how to write the output equation? It's very simple. So here I have 0, 0. For 0, 0, I have my I0. Okay. So for 0, 0, another concept, guys, please remember, there can be an enable pin here with this. If enable is 0 for any value, so your output will be 0. Assuming that for all these cases my enable is 1. Okay, so please keep that in mind and you can just go ahead with the problem now. So how to write the output? So it is y is equal to, see, observe here, S1 is 0, that is S1 bar. S0 is 0, that is S0 bar. What is the output? I am getting I0 as my output here. So the answer will be S1 bar, S0 bar and I0. Okay. Plus, what is my second output? That is I1. So what is the equation that I am having? S1 bar, S0 and I1. Like that. What is the third output? It is S1, S0 bar and I2. Next, fourth is S1, S0 and I3. So after writing this, I need to draw my circuit diagram. So this is the last stage for your problem. So how to write my circuit diagram? See, two variables, two select pins that I am having. One is S0, second one is S1. So S1 is having S1 and S1 bar. S1 bar means I am subjecting it to a NOT gate so that it produces S1 bar here. So the negation of S1. Similarly, S0 and S0 bar. So two lines, the 4 lines I have taken. This represents S1, S1 bar, S0 and S0 bar. After writing this, so you need to write. See what is the symbol which it is having. So it is having plus symbol. It is adding all the terms here. Within the terms there is a multiplication operation, so that I'll be using AND gate here. So how many terms I am having? 3 terms. S1, S0 and I0. So 3 input. So what is the first term which I am having? So I'll be using, first of all I'll be using, within this particular term I'll be using an AND gate to multiply this. When I am adding my first term with my second term, I am using my OR gate. Okay. So now first I'll be writing the equation for first term, S1 bar, S0 bar with I0. I'll be taking S1 bar, S1 bar. So I'll just write like this, S1 bar. Next I'm having S0 bar with I0. So this is your first term. Okay. Next S1 bar, S0, I1. S1 bar, I'll be taking like this. S1 bar. Next I have S0, and with I1. Third term I am having S1, S0, I2. S1, I'll be taking S1, and S0 bar, and I2. Next I am having S1, S0, I3. S1, okay, S1 and S0 I am having here with I3. So after doing this multiplication, here I will be getting, what I will be getting? S1 bar, S0 bar with I0. Likewise here with I1, here with I2, here with I3. So after all this, I will be subjecting it to your OR gate. See, it is 4 input OR gate, or else you can use 2 OR gates, then you can just sum it totally. So that it will become your finalized equation y. Y is equal to the same answer. So this is all about your 4:1 multiplexer. So please go through the video again. If you have any doubts, you can just ask in your comment section. So by the next video, we'll be discussing about 8:1 multiplexer and 16:1 multiplexer. Thank you.